All right, today we're going to be continuing on with Chapter 8. We're going to be doing lessons 8.6 and 8.7. They're both really short lessons and fit together really well. So we're going to be working on the law of sines and the law of cosines. So we've talked about the trig ratios in a few different lessons now. You've done some activities on Khan Academy with it. You've done some stuff out of the book with it. Again, those trig ratios you can always remember with SO katoa. So, sine is the opposite over the hypotenuse. Ka, the cosine, is the adjacent over the hypotenuse. And toa, tangent, is the opposite over the adjacent. And so today we're going to be looking at two of those, the sine and the cosine, and talking about some laws or some rules that go along with those. So what those are is, first we're going to go over the law of sines, which tells us that in any triangle there's a special relationship between the angles of the triangle and the lengths of the sides opposite the angles. So again, this can be used in any triangle. It does not have to be a right triangle. So the law of sines tells us that the sine of angle A over the length of side A is equal to the sine of angle B over the length of side B, which is equal to the sine of angle C over the length of side C. Now, if we look at an example of a triangle here, let's just draw that in, and let's go triangle A, B, C. Remember, you always use uppercase or capital letters to name a triangle. So we have, or to name the angles on a triangle. So we have angle A, angle B, and angle C. Then the sides, side A is always the side that is across from angle A, or opposite of angle A. Sorry, board stopped working here. So again, side A, we will use a lowercase a, and it will always be the side opposite angle A. So then side C will be the side opposite angle C. Side B is the side opposite angle B. So again, the sine of angle A over the length of side A, or over the opposite side, could be equal to the sine of angle B over the length of side B. So I'm going to go ahead and go straight into some examples here. So let's go ahead and do number 1. We have a triangle we know that two of the angles are 40 degrees and 80 degrees, and we're given the two sides that are opposite those angles. I'm going to move this a little bit closer to see if it helps you out on being able to see these a little better. Again, this is up on Schoology as well if you want to pull that up to be able to look at it as you're following along here. So we have 80 degrees. The opposite side is x, is a length of x. Then we have an angle with 40 degrees, and the opposite side has a length of 12. So what we would do in order to solve this is we would say that the sine of 40 over the length of the opposite side, which is 12, is equal to the sine of 80 over the length of the opposite side, which is x. Now, a couple different things we could do here. The long way would be to do sine of 40 divided by 12, then we would have to multiply x over to both sides and then divide. The easier way to be able to do this, if you remember, we have two ratios set equal to each other, so in order to solve for a missing length or a missing value, we can cross multiply. So this would become the sine of 40, or x times the sine of 40, is equal to 12 times the sine of 80. Then to get the x by itself, we would divide both sides by the sine of 40. So then on our calculator here, we're going to go 12 times the sine of 80, and we're going to divide that by 40. Or whoops, sorry, not by 40, by the sine of 40. So again, 12 times the sine of 80 divided by the sine of 40. And this tells us in the instructions to round to the nearest tenth. So we would say that x equals 18. It gives us 18.38. So to the nearest tenth, that would round to 18.4. So again, we used the law of sines, and we were able to find that missing value, which in this case was a side length. I'll go through one more of these. I'm going to do number 2 here. So for number 2, again, we're given 2 angles. In order to use the law of sines, you always need to have at least 2 angles and the lengths of the sides that are opposite them. So here we have angle, let's go ahead and name these, A, B, and C. You have angle A, which is 52 degrees, and you have the opposite side length, which is x in this case. Then we have angle B, which is 91 degrees, but we don't have the length of the side opposite that. So what we need to do, we're given this side length, so we need to figure out what angle C is. Now in order to do that, we know all 3 sides add up to 180 degrees. So we could say 91 plus 52 would give us, what's that, 143. Then we can do 180 minus 143, which would give us 37. So angle C is 37 degrees. So now we have angle A with its opposite side length and angle C with its opposite side length. So we can go ahead and say that the sine of A, which in this case is 52, so the sine of 52 over its opposite side, which is x, is equal to the sine of C, which is 37, over its opposite length, which is 20. Then again, to solve, we're going to cross multiply, which would be x times the sine of 37 is equal to 20 times the sine of 52. And then just like we did over here, we would now need to divide both sides by the sine of 37. So that would cancel. And we would get an answer of 20 times the sine of 52 divided by the sine of 37. 26.187, which we need to round to the nearest tenth, would give us a length of 26.2. So again, that's using the law of sines to find a missing side length. Next, let's see, are these the same? Are we still finding missing side lengths? Yeah. I think you guys are good on this. Again, you can always look back through those first couple examples that we did together. Here we would really be doing the same thing. We would just be using those angles, the 2 angle measures, and the opposite sides in order to find our missing side lengths. So then next, that was the law of sines. Next is the law of cosines. So again, if we think about it for the law of cosines, law of sines was when we were given 2 angles and one of the sides, and we were finding the missing side length. The law of cosines, it says another relationship between the sides and angles of any triangle is called the law of cosines. You can use the law of cosines if you know 3 sides of a triangle, or if you know 2 sides and the included angle of a triangle. So our two different options for using the law of cosines is if we know all three sides, or if we know two sides and the included angle. Again, the included angle means that it is the angle in between the two sides that we are given. So the law of cosines, let triangle ABC be any triangle with A, B, and C representing the measures of the sides opposite the angles with measures uppercase A, B, and C. So again, that's just telling us the same thing we talked about on the last slide. If you have triangle ABC, your angles are always named with uppercase letters, and then the sides opposite them are going to be using the same letters but the lowercase. So angle B, the opposite side, has a length of B, or is called side B. So the following equations will represent the law of cosines. A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. Or B squared equals A squared minus C squared minus 2AC cosine B. Or C squared equals A squared plus B squared minus 2AB cosine C. Now they have a little typo here on this one. This middle one, the B squared, should be, I'm a little off. Should be A squared plus C squared minus 2AC times the cosine of B. So, again, I'm going to skip their couple of examples and just get into a couple here that I'll explain as I go along. So we are supposed to find x, round angle measures to the nearest degree, and side measures to the nearest tenth. So for number 1 here, we're finding a missing side. So, number 1, we're trying to solve for x, which would be, since this is angle A, this would be side A. So since we're trying to solve for side A, if we look up at our equations here, we would need to use the first one because we're solving for side A, so we need to use the one that starts with A squared. So if I go back here, I'm going to use my A squared equals B squared plus C squared minus 2BC times the cosine of angle A. So now if I plug in values, A squared equals B squared. Remember, since angle B is here, side B would be opposite. Angle C is there, so this would be side C. This would be side A. So B squared would be 14 squared plus C squared, which would be 12 squared, minus 2 times B, which is 14, times C, which is 12, times the cosine of A, which angle A is 62 degrees. So I plugged in all of the values that I need there. Now I just need to simplify this. So I'm going to go ahead and do 14 squared plus 12 squared. I'm going to get A squared equals 340. Again, that was 14 squared plus 12 squared. Then I'm going to do 2 times 14 times 12 times the cosine of 62, which gives me 157.742. I'm going to go ahead and round to the nearest tenth. So 157.7. So now when I do my subtraction, 340 minus 157.7, I get A squared equals 182.3. So now that I've got that, to get rid of my square, I need to take the square root of each side. That cancels. And I would get the square root of 182.3. Again, since this is a side length, it said round to the nearest tenth. So I would get a length of 13.5. So again, to determine which equation I needed to use, I just looked at my missing side was side A, so I used the one that starts with a squared. The other way you can look at it is we're given angle A and sides B and C, so we use the one that all of our given information will be included on that right side. So that was number 1. Next, I'm going to go ahead and do number 3 here. So this is the other situation in which we can use the law of cosines. The first one was when we're given 2 sides and the included angle. This one is when we're given all 3 sides and none of the angles. So for this one, we are trying to find angle C in the end. So for this one, instead of being able to tell which equation we want to use based on which side we're solving for, we're going to determine which equation we want to use based on the angle that we're solving for. So since we're solving for angle C, if we go back up to our equations here, we want to use the equation that includes angle C. So this one includes the cosine of angle A, cosine of angle B. This one here includes the cosine of angle C, so we're going to go ahead and use that equation for the law of cosines. So what we're going to do here, the one that we're using is C squared equals A squared plus B squared minus 2AB times the cosine of C. So using that equation, we're going to plug in our missing values. So side, again, the sides are opposite the corresponding angles. So this would be side A, side B, and side C. So for C squared, we would say 16 squared equals A squared would be 24 squared plus B squared would be 18 squared minus 2 times A times B. A and B are 24 and 18 times the cosine of C. And we don't know what angle C is, so we're going to leave that for now. So 16 squared gives me 256 is equal to 24 squared plus 18 squared, which gives me 900 minus 2 times 24 times 18, which is 864 times the cosine of C. So here I can't combine these two values. I can't do 900 minus 864 because those are not like terms. 864 has the cosine of C with it. That would be like having 864x, which means that we wouldn't be able to combine those terms. So what I need to do instead is go step by step to solve for the cosine of C. So I'm going to start by subtracting 900 from both sides. Those cancel. 256 minus 900, I would have negative 644 equals negative 864 times the cosine of C. So then I need to divide both sides by negative 864. So here, that would cancel. Negative 644 over negative 864 would give me 0.75 is equal to the cosine of c. And then just like you've done in the last couple lessons, if you have the cosine of c is equal to a number, then you could change this to saying that the inverse cosine of 0.75 is equal to c. So we would, on our calculator, inverse cosine of 0.75. And again, in the instructions, make sure you pay attention there. It told us to round each angle to the nearest whole number. So we would say that c is equal to 41 degrees. And that would be our answer there using the law of cosines. Again, if you need to rewind a little bit, go back through anything, feel free to do that. We're going to go through one story problem example here, and then we will be done. So, indirect measurement. When the angle of elevation to the sun is 62 degrees, a telephone pole tilted at an angle of 7 degrees from the vertical casts a shadow 30 feet long on the ground. So before I try and solve anything, I'm going to draw out a diagram for this. I'm going to go ahead and draw in my triangle. I've got the sun up here, so I'm going to use that. I'm going to say angle S because the sun is up here. This is going to be a 90-degree angle when the angle of elevation to the sun is 62 degrees. So let's go angle G coming from the ground. The angle of elevation looking up at the sun is 62 degrees. A telephone pole tilted at 7 degrees from the vertical. So here, the vertical would be right here. That's our 90-degree angle. I've got a telephone pole that tilts up at an angle of 7 degrees. So this is going to be my telephone pole. Let's go with angle P there because we have our telephone pole coming up from that angle. So that's a 7-degree angle. It tells us that the telephone pole is at tilts at a 7-degree angle from the vertical. So that's all of our given information. Oh, one more. Casts a 30-foot shadow. So a 30-foot shadow there. So what we're going to do here is we need to figure out the length of the telephone pole to the nearest 1/10 of a foot. So in order to do that, we need to come up with a couple of missing measurements. That pole's going to go all the way up there. Those missing measurements we need to come up with are for this triangle here. We need to come up with this measurement and this measurement. This one is pretty easy. If we know that in our blue triangle, this is a 90-degree angle, and that the angle the pole makes with the vertical is 7 degrees, we can do 90 minus 7, which gives us an angle of 83 degrees there. Then, for this missing angle, we know that all three of them have to add up to 180. So we can say 62 plus 83, which would give us 145. Then we can do 180 minus 145, which gives us 35 degrees. So we have all three angles here, and we have one side. So based on that, we need to determine, can we use the law of sines or the law of cosines here? For the law of cosines, we know that we have to have at least two of our missing angles. So in order to do this, we can't use the law of cosines. We need to use the law of sines here. So we're trying to solve for this length of the telephone pole. which means we know we're going to have to use the angle opposite of that. So we can say that the sine of 62 over the opposite side, which is x, is equal to, in order to determine which other angle we need to use, it's going to be the one that we're given the opposite side for. So 35 degrees and 30 feet. So we'd set it equal to the sine of 35 over 30. Then again, just like before, to solve this, we're going to cross multiply. So x times the sine of 35 is equal to 30 times the sine of 62. Then we need to divide both sides by the sine of 35. So 30 times the sine of 62 divided by the sine of 35. They tell us to the nearest tenth of a foot. So we would say 46.2 feet would be the height of the telephone pole. There's your assignments right there for 8.6 and 8.7. Again, these notes are up on Schoology like normal, so feel free to go back and take a look at those if you need to. Remember that you can always use Khan Academy as another resource. I know we're going back to using more of this style of me teaching and doing assignments out of the book, but always feel free to go back onto Khan Academy, watch the videos, do some practice problems if you need to. And then on Google Classroom, I will have assignments set up for this, and you guys will just upload your assignments like you have been doing. For the most part, you guys are doing a great job. If you're still a little bit behind on those, please make sure that you are getting caught up on it. I want to be showing some grace on this, but at some point I do have to start putting some incompletes in the gradebook. So please, if you're a little bit behind, make sure you're getting those assignments to me as soon as you can. Let me know if you guys have any questions.